हेलो हेलो। और भाई, कैसे हो? तो आज हो गई हमारी 100 डेज की स्ट्रिक अचीवमेंट। तो आज हम सॉल्व करते हैं लीड कोड क्वेश्चन प्रॉब्लम ऑफ द डे। सो लेट्स सी व्हाट दिस क्वेश्चन सेज। Okay, the question says remove methods from a project. Okay, so let's see what it is. You are maintaining a project that has n methods. Okay, so we are given n methods. They are numbered from 0 to n minus 1. Okay. Then we have given two integers n and k and the two array invocations. Okay. Invocation says AI invocates BI, means there is a directed edge from AI to BI. Okay. Note says this edge is directed. Okay. So it's not undirected first of all. Okay. Undirected means if there is a edge from A to B, it's written like this. It means you can go from A to B and you can come from B to A, both. But this is directed. It means only one way. Okay. A group of methods can. Okay. There is no bug in method K. Okay. Method K is a buggy. Okay. Along with any method invoked by it, either directly or indirectly, are considered suspicious, and we aim to remove that. Okay. And they're saying there is a method K which has bug, and they want to remove all methods, right? Which are directly or indirectly invoked by K. So basically all dependents on K. Okay. And a group of method can only be removed if no method outside that group invokes any method within it. What does it mean? It means, let's say there's for example, you see this case, say that let's say K equals to 0, right? This means this one is faulty. Okay. Then see, 0 invokes 3, right? 0 invokes 3. But 0 to 3 you can come, but is there any other where you can go? No. Okay. Now see. So this is the one that we need to remove. Okay, now see. 1 has a direct dependency on 0. 4 invokes 3 basically. Invokes. So can I remove them? Can I remove them? No. Okay, now see similarly this case, right? Let's say k equals to 1. Okay. Now see. From 1 I can go 0. From 1 I can go 2. And from 0 we can go 2, right? See, 1 has a dependency on 0. 0 can go to 2, so we'll write 0, 2. So these we have to remove, right? So 0, 1, 2 need to remove. Okay. Now, see, is there any other method that is outside this one, right? Right, that is connected to them, right? See, 3 only connects to 4, right? So no, right? No outside, right? Right? Okay, so then we have our then we are going to remove 1. So you remove 1, 2, 3. So we are going to remove 1, 2, 3. And in the end, we have to return the whatever is left. Okay. So see this first example. There is a from 1 to 2 we have a A's. From 0 to 1 we have a A's. And from 3 to 2 we have a edge. Okay. And K equals to 1. Okay. Then our group equals to what? From 1 you can go to 2, right? That's only this much group. Now outside, what do we have outside, right? Outside we have 0, we have 3. Now 0 to 1 there is s, 3 to 0 is n. So none remove, right? So we are going to remove none of them, right? So just return it now. So we return 0, 1, 2, 3. Okay. So now I think you got a hint what we are going to do, right? First thing is what? Find all connected, right? File find all connected methods, right? From K. This is our first step, right? We are going to find everything that we can reach from K. So for example, there is a K. You can go to x1, you can go to, let's say, x2. From here you can go to x3 and so on. So how we do this normally via DFS. Now second, once you find this thing, right, then let's say you, okay, you have this. Then second thing is find if any node outside, right, invokes any method in above group. Okay, so how can you do this? See, we have given two things, right? We have given an invocations array, right, that is consist of AI comma BI, right? Now that means AI has edge to BI, right? See, when you find this all connected component, let's say you have a set of some K, there is X1, there is X2, right? And so on, so on. Now, so how you can find this? You see this. So this AI, right? This AI for any pair AI comma BI, this should not be part of connected, right? And BI is what? Should be part of connected, right? So this is the condition, right? Then this is simple. So let me take a screenshot for this one for reference. Uh, See, there are only two steps in this question. So first is we have to find all the connected component, and second is find if there is a outside edge that connects to these components. There is an edge basically. Okay. Now how we are going to do first, right? First is we have to do a DFS. Okay. So for DFS we need a graph basically. Graph, or let's say adjacency list, right? So you say, let's say Z1 has edge to 2, 2 has edge to 3, comma 4, 4 has edge to 1, then what do we say? 3 has edge to 2, right? Let's say this is our graph, adjacency list, you say, whatever. You can use a 2D array as well, but that is most of the time, right? The cost ineffective. So we don't use this. This gives us MLE. So we directly use this one, okay? So in our, see, in our DFS, from 1, let's say if k equals to 2, then what do we do? If k equals to 2, we go from 2 to 3, we go from 4, right? Then from 3, I can go to 2 again. So, right, this will be infinite loop, right? Infinite loop. So we need to keep track of visited. Okay. Now from 4, I can go to 1. From 1, I can again go to 2. Okay, so again, right? So that's uh, for that we keep a visitor. So this is simple, right? In our DFS, we'll pass our adjacency, we'll pass our K, and we are going to pass a visited array. Okay, so what do we first check? Let's say from 2, I go to 3. So I'll check if already visited or not, right? If already visited or not. मतलब हम पहले इस पे आए हैं कि नहीं आए हैं, see. So what do we do? If visited of k, right, then what can, right, simply return, that means we have already traversed all branches of this one, right? So let's say there is a 4, let's say 5, right? Okay, if it's not, then we visit it, right? We mark it true. That means in this particular branch we have visited it. The next is what? See, for all childs, right, we have to loop for all childs, right? uh Loop over all childs of k, right? Then for each, what you are going to do, see, if it's not visited, right, if you haven't visited this child before, then what you are going to do, you is just simply call our DFS adjacency list. Now k will be whatever child, right, and you simply pass them visited. So this is the simple visited, right? This is a simple DFS. So after this DFS, what do we have? We have a visited array. which will be like what? So it's a 0, 1, 2, 3, 4. So in above example, if I write, so in above example, we have taken right k equals to 2, and from 2, what happened? See, from 2, let's say you can let me mark it clear, okay? From 2, right, you can go to 3, see, and you can go to 4, okay? Then from 4, you can go to 1, right? So basically, we can go to 1, 2, 3, 4. Okay, so G, so this is true, this is true, this is true, this is true. Okay, now the next step will be what? See, we have visited, right? The next step is second. Check if, right, any outside. See, check if any outside method. So मतलब बाहर कोई एक ऐसा एज है अपने पे जो इसके बाहर है, मतलब इन सब से, इस पूरे सेट से बाहर है विजिटेड से, और वो इन्वोक करता है एनीथिंग दैट इज इनसाइड विजिटेड, राइट? सी, जो मतलब नहीं विजिट हुआ होगा उनको तो हम क्या मार्क करने वाले? फॉल्स. सो कैन आई से दिस एफ, राइट, this is outside, and can I say this one is inside, right? Wherever value is true, that means it's inside, otherwise it's outside, right? So how, what we are going to check this simply, right? We write, for we loop over our invokes, right? For what I equals to 0 to, right, our invocations dot length. So right, we simply loop over all edges, right? Okay, then what you are going to do, we'll check, right, if what, see, invocations is two part, right? UI comma vi. Sorry, a, let's say a b, right? So that's simplicity, right? The a should be outside and b should be inside, right? So that means if what, visited of a equals to what, false, and visited of b equals to true, इसका मतलब क्या हुआ कि outside, right, outside to inside edge. So that means we can't remove. So if we can't remove, then we mark, let's keep track of some flag. So we'll do flag equals to false. So initially the flag, right, flag equals to true, that means we can remove, or that means we can't remove. Okay, then now in the end is simply, right, we construct answer. Construct answer is for, say, construct answer is simply, right, we in our visited, right, in our visited consists of like true, false, and so on, right? See, then we just need to loop over, right, this visited 0 to n. Say if what, see, if flag is true, right, then only we can remove, right? If flag is not true, we cannot remove, right? मतलब we can remove. So we simply continue. Otherwise, what do? We add this, right, current to our answer. Answer dot add whatever say. So this answer is our answer. Now let's analyze the time complexity. See, the question is simple. First step was find all connected methods from K. Second step was what? Find all nodes if there is any connection from outside to inside. Once that is done, the question itself is very easy. Okay. See. Right. Make sense? I think this is clear, right? Okay. So once this is done, then time complexity for this is what? See, we never traverse one node again. So this will be of simply n only, right? What is the time complexity of this one? This one is of m, right? M is what? Length of invocations. So what is the time complex? This one again of n. So time complexity is what? Of n plus m. Space complexity is what? Of n. Now, see, I'm I'm not coding it again, okay? So I'll share the link in the description. You check the link in the description and code by yourself. See, don't try to see the code. Try to see once. Now you have all the three steps, right, that you need to do. Complete them one by one, and I'm sure you will be able to get to the answer. Thank you.